Under this unit, we are having the following topics. The first one is higher order linear differential equations with constant coefficients. The second one is method of variation of parameters. The next thing is homogeneous equations of Euler's and Legendre's type. The last one is system of simultaneous linear equations with constant coefficients. After completion of this learning, students can able to analyze various techniques in solving ordinary differential equations. The first, we move on with higher order linear differential equations with constant coefficients. For learning in that, we must want to know some basic terminologies like what is differential equation, so what is ordinary differential equations, what is an order and degree, and what is a linear differential equation. These are all the basic things we need to learn before that. So first thing is, what is a differential equations? A differential equation is an equation involving an unknown function and its derivatives. So look at the examples. So here unknown function is y and its derivative is dy by dx. In dy by dx, y is an dependent variable depending of x and x is an independent variable. So here also the unknown is y and derivative is d square y by dx square. These are all the differential equations. So next, types of differential equations. So we have ordinary differential equations, partial differential equations, linear differential equations, non-linear differential equations, homogeneous type and non-homogeneous type. These are all the various types of differential equations. So let us going to start ordinary differential equations. An ordinary differential equation is an equation that contains one or several derivatives of an unknown function of one variable. So we may have more than one derivative terms in a particular equation, but all the derivative with respect to one and only variable. Examples are here. So here derivative only one derivative, that's not an issue, but with respect to x alone. Here also only one derivative, that is with respect to x. Here we are having two derivatives, both the derivative with respect to common variable x. So therefore these are all the examples of ordinary differential equations. So here also more than one differential terms are there. So therefore both are with respect to x alone. So therefore these are all the example of ODE. Next, we are going to learn about order. So differential equations are classified on the basis of order. So order of a differential equation is the order of the highest derivative which present in the equation. Order of the highest derivative is the order of a particular equation. Let us have an example. So here the derivative highest order is also dy by dx. Here the order of immediate power of d is the order. So here d power is 1. So therefore the order of this particular equation is 1. So the first example is a first order differential equation. And the second example, the derivative order is 2. D power 2. So therefore this is second order differential equation. Here two derivative terms are present here. So therefore you must choose the highest derivative power. So d square y by dx square is the highest power. So the highest order. So therefore which decides the order of this particular equation. So therefore in this particular equation is a second order differential equation. So we are going to discuss about degree. The degree of differential equation is represented by the power of the highest order derivative in the given differential equation. So highest derivative power will decide the degree of a particular equation. So go through the example. So d power among this derivative, d power 4y by dx power 4 is the highest derivative. So this exponent value is 1. So therefore the whole differential equation degree is 1. So look at these examples. Here dy by dx whole power is 1. So therefore here degree of this equation is 1. D square y by dx square whole power is 1. So therefore this also having the degree 1. So here two terms are there, dy by dx whole square and dy by dx. So therefore this order is, this exponent value is 2. So this particular equation degree is 2. So look at the next example. Here whole power we are having the rational number. For this such kind of cases we must want to rationalize at first. After rationalizing we must look up the highest derivative power. So therefore highest derivative power here is 2. So therefore this particular equation degree is 2. So we must move on to the linear differential equation. A differential equation is called linear if the unknown function and its derivatives occur in the first degree only. So all the derivative power exponent value is must be 1. So therefore it is linear. Otherwise it is called non-linear. So let us have the nth order linear differential equation is like d power n y by dx power n plus a1 into d power n minus y by dx power n minus 1 plus etc. plus an into y is equal to f of x. Here all the derivative power value is 1. So therefore which is linear equation. So order of this particular equation is, highest order of this particular equation is n. So therefore this is nth order equation. In our RHS side we are having f of x. This is a function of x, so which means it may be a exponential or trigonometric or some other algebraic terms also will come in this place. So here a naught, a1, a2 etc, an or these are all constant values. Okay, next we are going to write the operator form of this particular equation. For that we just want to replace this d by dx into capital D. So for all the terms we are having y in the numerator, we just keep that into out. So we must have the operator form of the previous case is d power n plus a1 into d power n minus 1 plus etc an into y is equal to f of x. We just want to replace d is equal to d by dx here. So the solution of this particular equation consisting of two parts, that is complementary function and particular integral. Suppose we must be having RHS value 0 means we have to find out alone the complementary function. So because the particular integral depending the RHS function only. So therefore RHS value 0 means we no need to go for the particular integral. You have to stop complementary function itself. That is the general case. So next we are going to find the complementary function. How to find the complementary function? For finding the complementary function, we just want to write the auxiliary equation at first. For that we just want to replace d is equal to m in the previous operator form and f of x is equal to 0. Suppose as such they are given right hand side 0 means no need to go for f of x equal to 0. I just want to replace d is equal to m in the operator form. So after replacing in the above previous slide, we must get the auxiliary equation is in the form. So after solving this particular one, we are getting the roots are like m1, m2, etc, mn. That means what? N roots are here, because we are having the order of this particular equation is n. Therefore, we must get n roots. Order of this equation is 2 means we will get only 2 roots. Order of this equation is 3 means we will get only 3 roots. Likewise, we will get the roots here. So next, the formulas for finding the complementary function. At very first one, the roots are real and different. So roots must be real and different means the complementary function will be like complementary function is equal to a into e power m1x plus b into e power m2x plus c into e power m3x. We have to trim the formula. Suppose we are having only 2 roots means we have to trim up to the second term. Suppose we are having 3 values for m means go for the up to third term. So likewise we need to develop the complementary function for real and different cases. So next, repeated roots. The roots must be real and repeat. Means repeat means what? All the roots are equal means we need to go for the complementary function as like ax plus b into e power mx. So the last thing is imaginary. the roots are imaginary. The roots are imaginary is in the form alpha plus or minus I beta means. So the complementary function formula e power alpha x a cos beta x plus b sin beta x. Alpha is a real part and beta is an imaginary part. These are all the formulas for finding the complementary function. So next we just having some examples under complementary function. The first problem, solve d square plus 3d plus 2 into y is equal to 0. So for writing the, at very first step, we need to write the auxiliary equation. For writing the auxiliary equation, we just want to replace d is equal to m in f of d in the given problem. So after replacing it, I will get the auxiliary equation is m square plus 3m plus 2 equal to 0. We can able to factorize. We can able to factor easily without using the formula. So multiplicative values 2, addition values 3. So therefore the factors are m plus 1 into m plus 2 is equal to 0. So after equating each factor into 0, I will get the roots are minus 1 comma minus 2. So which these are all the real case and distinct. So therefore the complementary function is a into e power minus x plus b into e power minus 2x, m1x, m2x. The general thing is, the general solution of this particular problem is only the complementary function, because RHS value is 0. No need to find the particular integral here. So next thing is d square plus 2d plus 1 into y is equal to 0. RHS 0. Find only c dot f. So auxiliary equation is here. M square plus 2m plus 1 equal to 0. After factorizing, I will get m plus 1 is equal to 0. So equating each factor into 0, the roots are minus 1 comma minus 1. Two roots are equal, repeated. So therefore the complementary function is ax plus b into e power minus x. The general solution is y is equal to complementary function. The last thing is d square minus 4d plus 13 into y is equal to 0. The corresponding auxiliary equation is m square minus 4m plus 13 equal to 0. Here we cannot able to factorize this directly. So therefore, in such case, we are going to use the quadratic formula x is equal to minus b plus or minus square root of b square minus 4ac by 2a. Here a is equal to m square coefficient, b is equal to m coefficient, that is minus 4, c is equal to 13. a1, b minus 4, c 13. After replacing it into this particular formula, I will get the form like, after simplifying this, I will get 2 plus or minus 3i. At last, I will get m value 2 plus or minus 3i. Here alpha value is real part, that is 2. Beta value is coefficient of I, that is 3. So complementary function is e power alpha x, 2x, a into cos beta x plus b into sin beta x. The general solution is the corresponding complementary function alone. So in this lecture, we learned about what is differential equation, what is an ordinary differential equation, so how to find the complementary function. These cases only we are discussed about. So in the next lecture, we are going to see what how to find the particular integral and what are all the types are there in that. So thank you.